Alright, good day. Now we're going to review our understanding regarding trigonometry, okay, because this will be very crucial for our understanding about vectors. So first, let's define the Cartesian plane. Look something like this. So here, this would be our quadrant 1, correct? Then this is our quadrant 2, this is our quadrant 3, and this is our quadrant 4, right? So for the first quadrant, the values are positive and positive for the number pairs. Then for here, it's negative positive, negative x, positive y. Okay, for the third quadrant, it's both negative. Okay, then for the fourth quadrant, it's positive, negative. Okay, next thing that you have to remember are the angles. So the angle for the first quadrant is between 0 to 90 degrees. Okay, how about we write the angles instead? So we have 0 degrees here, then this is 90 degrees here. So from here to the positive x-axis going to the positive y-axis. Okay, so that's our first quadrant. Then 90 going to 180 degrees. Okay, for the negative x-axis. Okay, then from 180 going to the negative y-axis is 270 degrees. Okay, then last but not the least, going back is, of course, it's also the same as 360 degrees. Okay, so those are the things that you have to remember for the basic principles of Cartesian plane coordinate system. Okay, next thing that we want to review is the triangles and the trigonometric functions. Okay, so to determine the angle, when asked about the direction, if you remember, vectors must have magnitude and direction, right? So for the magnitude side, that would be obtained through a certain set of equation, primarily Pythagorean theorem or the distance formula. In the case of direction, we have the trigonometric functions to determine the exact direction of where that particular vector is going. So as a review, we have the three cases here. Okay, so if you still remember your parts of the triangle, so let's take this first triangle. So this is our angle, which is, okay, this one, which is the theta. Okay, so opposite to that angle, that leg is what we call, of course, the opposite, and the longest side of the triangle is the hypotenuse. Alright, okay, for this particular scenario, so we have the angle here. This is the adjacent side. So adjacent meaning beside the angle, okay, which is of course the shorter leg because the longer leg is the hypotenuse. Then lastly, this particular scenario wherein the angle or theta have one that is opposite of it and one that is adjacent to it. Okay? So for this first scenario, what we use is the sine function. Okay, so to determine the angle when these are the given, okay, would be sine inverse, so sine raised to -1 multiplied by opposite over hypotenuse. Okay? Next would be for cosine function. So to determine the angle when you are given one adjacent side and one hypotenuse side would be cosine inverse multiplied by adjacent over hypotenuse. Okay? Then lastly, for this scenario, when you are given one opposite side and one adjacent side, what you're going to use is tangent inverse or the tangent function. So theta would be equal to tangent inverse multiplied by opposite over adjacent. Okay, so as a mnemonic, we try to remember this. Okay, so katawa, right? Sine is opposite over hypotenuse, cosine is adjacent over hypotenuse, then tangent is opposite over adjacent. Okay?